This is section 4.2, and this is the third part. We're still talking about trigonometric functions using the unit circle. Today we're going to kind of look at domain and range, even and odd properties, and something called the periodic properties. So let's go ahead and get started. Our first objective is the domain and range of sine and cosine, and we're going to start with f of x equals the sine of theta. Now, when we're talking about the domain of the sine of theta, we're talking about all of our possible thetas that we can have. Now, that means our possible angles. Because we can go around the circle as many times as we want, clockwise or counterclockwise, that means the domain for theta is going to be from negative infinity to infinity. Now, in terms of the range, we have to think about the answers we get. Now, we get those answers off the unit circle. Remember, sine comes from the y values on our unit circle. Now, our lowest y value is -1, and our highest y value is +1. That means that our range is going to be from -1 to +1. Those are the lowest and the highest y values we could get. So our range of answers for sine of theta will always be between -1 and +1. When we're thinking about the cosine of theta, now we need to think of the same things. In terms of the domain, again, we can go around the circle as many times as we want in either direction, so it makes our domain negative infinity to infinity as well. And when we talk about the range, this time the answers for cosine of theta come off the x values. The lowest x value is -1. The highest x value is +1. That makes the range the same thing. So you can see in this case that both the domain and range for sine and cosine are the same. The domain is negative infinity to infinity. We can have as many angles as we want. We have an infinite number of options here. The range, though, will always be from -1 to 1. Our answers will never be anything but from in between -1 and 1. All right, moving on. We're going to use the even and odd properties of trigonometric functions. Now, the first thing we want to remember is, what does it mean to be even and odd? Remember from chapter 1 that if we plug in a negative x into our function and we get back what we started with, it makes it even. If we plugged in a negative x and we got the opposite answer, it made it odd. So we're going to use those ideas to help us look and decide about our trig functions, which ones are even and which ones are odd. So let's take a look at the sine of negative theta. Now, in order to do this, I'm going to use the point pi over 4, and we know that was root 2 over 2, root 2 over 2, as my angle, and we learned that in the first video in 4.2. And then I'm going to use the same one but negative. Now, if I flip that one downwards to make it negative pi over 2, the x value stays the same, but what changes is the y value. The y value, notice, has now become negative root 2 over 2. So now we're taking a look at the sine of negative theta. Notice that the sine of negative theta is negative root 2 over 2. It's the opposite of the sine of positive theta. So because it's the opposite, I can say it's the negative sine of theta. Now let's look at cosine. Cosine's the x values. The x values are exactly the same, so cosine doesn't change whether or not the angle is negative. Tangent, remember, is sine over cosine, or y over x. Now, in the positive angle in purple, when I do y over x, I get a +1. But in the negative angle in green, I get a -1. So notice that in terms of tangent, it's the negative. Now, since cosecant is the reciprocal of sine, it's going to be similar to sine. We'll get negative cosecant. Secant is the reciprocal of cosine, and notice that means it's going to become just the same as the positive angle. And cotangent, the reciprocal of tangent, will turn into negative cotangent of theta. So now what we need to decide is, out of these, which are even and which are odd. Notice if the function is even, we get to completely ignore the negative sign because the negative angle and the positive angle give you the same answer. For the odd functions, we get to pull the negative sign out into the front of the function. We'll see in our examples more how this is used. So, looking for our even functions, it looks like we have cosine and secant, because the cosine of the negative angle is the same as the cosine of the positive angle. So cosine and secant are our only even functions. And in terms of our odd functions, we have sine, cosecant, tangent, and cotangent. So basically all the rest are odd. So that means that if I am taking the cosine of an angle that's negative, I can just ignore the negative and just look at the positive angle. And if I'm taking the sine, cosecant, tangent, or cotangent of a negative angle, I can pull the negative out in front. Now the nice thing about these properties is it allows us now to only have to think about our unit circle going clockwise. We no longer have to count counterclockwise, which a lot of us have a difficult time doing. So let's look at a couple examples. Here's the first one, the cosine of negative pi over 4. Now, pi over 4 is an even function, so that means we get to ignore the negative sign, and we just get to look at the cosine of pi over 4. Now remember, that's the same point we've been dealing with, that root 2 over 2, root 2 over 2. So that means that the cosine of pi over 4 is the x value, and so the answer is root 2 over 2. Sine of negative pi over 4. Now sine is an odd function, so we're going to pull the negative out into the front. So we have negative sine of pi over 4. Now when I look at the y value, the sine of pi over 4 is root 2 over 2, but then it's going to be negative because the negative out in front. So you can see now that even though the original angles were negative, we got to use the positive angle to find the answers. And that's how the even and odd trig function properties can help us. The last set of properties we want to talk about is the periodic properties of the trig functions. Now, the one thing you need to know is that when I say periodic, it means basically a period is how long the function takes before it starts repeating answers. So it's one cycle of the function before the answers start getting repeated. Now let's look real quick at a circle, and I have that pi over 4 point, root 2 over 2, root 2 over 2. We've seen that over and over again. If I flip that point into quadrant 2, notice that the x value becomes negative, but the y value stays positive. If I flip it down into quadrant 3, both x and y become negative. And if I flip it into quadrant 4, the x is positive, but the y is negative. Now, let's think about sine for a minute. Sine is our possible possible y values. Now notice that in terms of these y values, it starts at a negative root 2 over 2, and then it's, positive, and then it's positive again, and then it's negative, and it's negative again. There's really no pattern here. It takes the entire way around the circle before we'll start repeating the answers again, because we'll have to go positive, and then negative, and then negative. So what that means is that sine of theta, for every set of 2 pi I add to it, it's the same as the original. So basically every set of 2 pi I get to ignore. Now the same goes for cosine. Cosine doesn't start repeating until I've gone all the way around the circle. So for cosine, I have to take a full time around the circle before I can start ignoring it, and then I get the same answers. The interesting thing is when we look at tangent and cotangent. So let's look at tangent for a minute here. Now tangent in this case in quadrant 1 is positive 1 when I use y over x. In quadrant 2 it's negative 1. Then I'm back down here at positive 1 and then negative 1 again. So you can see that halfway around the circle, these answers start repeating itself. That means in terms of tangent, and the same will go for cotangent, we only need pi sets before our answers start repeating. So every set of pi we get to start to ignore. So the big idea here for these periodic properties is that sine and cosine take sets of 2 pi. After 2 pi, you have to go all the way around the circle before your answers start repeating. But tangent and cotangent start repeating just halfway around the circle. We're going to look at some examples now that put it all together. So here's the first one, sine of 9 pi over 4. Now, 9 pi over 4 is more than one time around the circle, so I'm going to use the idea of coterminal angles and just break this up a little bit. I'm going to change 9 pi over 4 to be 8 pi over 4 plus pi over 4, and that's a total of 9 pi over 4. Now the reason I did that is because 8 pi over 4 is the same as 2 pi. And remember, we just said that we get to ignore sets of 2 pi for sine. So now I really just get to look at the sine of pi over 4, and that equals root 2 over 2. How about the next example, the tangent of negative 5 pi over 4? Now, I see a negative there, so first I want to think about even and odd properties. Tangent is an odd function, so we're going to pull the negative out in front. Now, the next thing I know is that tangent repeats after sets of pi. So I'm going to rewrite 5 pi over 4 as 4 pi over 4 plus pi over 4. Now 4 pi over 4 is a set of pi, so I'm going to ignore it. And now I just have to look at the negative tangent of pi over 4. So it's negative root 2 over 2 over root 2 over 2. Everything cancels out there, so we get negative 1. I'm going to break up cotangent of 5 pi over 4 in a similar manner. So I'm going to change that to 4 pi over 4 plus pi over 4 because cotangent repeats after sets of pi. So we get to ignore the 4 pi over 4 and just look at the cotangent of pi over 4, and that's going to equal 1. Alright, our final example for the video is the cosine of negative pi over 4 minus 2000 pi. Now, first off, let's look at that minus 2000 pi. That's the same as 1000 sets of 2 pi. We know cosine repeats after every set of 2 pi, so basically we just get to ignore all of those. And now we're going to look at cosine of negative pi over 4. Because cosine is even, we get to completely ignore that negative sign, and now we just want the cosine of pi over 4, which ends up equaling root 2 over 2. The last question here on this slide is your free response question for the video, so I want you to go ahead and answer this into your Google form. Then we'll move on to the last slide, and it's your multiple choice question, and you can also answer this one onto your Google form, and then you're done with your video for the day.